Okay, Pak Miki, I already assigned Pak Miki.
Yeah, okay. Oh. Okay, is my presentation visible?
Yes, sir.
Yes,
Okay,
Pak.
good. Okay, and a very good morning to everyone. This is our first meeting in this class, and I guess this is the first time that I'm meeting you guys as well. So my name is Walmiki. Yeah, I don't believe I have met your angkatan before, because I used to teach statistics for chemical engineering for the international class, but I didn't teach that class last semester. So this is the first time that I'm meeting you guys. Okay. All right. So, and the class title is Plant Utility Systems. This is a mandatory class, 3 SKS in total, and it's the regular schedule is today and tomorrow. Okay. There will be 3 faculty members in this class, me, myself, Pak Wawan, and Pak Hendra. Okay. Last year, this class was held roughly about 50% of the sessions were held together with the regular class, but due to response from the international students, we this semester we keep it separate throughout the entire semester. Okay, so this class will be administered completely separately from regular class, except if we have, if we decided to do some guest lecture or things like that, that would be joined between regular and international class. Okay. So as usual, in the first session of any class, we will just give you a quick overview of what's lying ahead for the rest of the semester. Okay. So, and this is the, well, of course, we can come back to this later on, but anyway, just a quick review of the course learning outcomes, which means that these are the things that you need to master by the end of this class. Okay. So you need to be able to compare the physical chemical characteristics of fuel and also principles of combustion systems and operation. Describe the requirements and production process of cooling water and boiler feed water, which will be taught by Pak Wawan. Calculate mass and energy balances of boiler and steam, distribution system and performance of steam turbines. Calculate the performance and energy conversion of internal combustion engines, which include gas turbines and piston engines as well. Number 5, discuss the general design and latest trends in cogeneration and combined cycle systems. And this is this technology is actually quite important, especially in the framework of emission reduction or carbon dioxide emission reduction throughout the world. Okay, and actually, we in chemical engineering has been dealing with this issue for, I think, for decades by now. Okay. So this is nothing new for us, but of course, this is an evolving technology, so there's always things that can be done better. And lastly, number 6, being able to describe the general design and operation of plant electrical generation and distribution systems, including electric motors. Now, we are all well aware that you are chemical engineers, so we're not trying to make you into electrical engineers, but of course, when you practice your profession after you graduate, there are other knowledge from other disciplines that you also need to, at least you are aware of that, and electrical engineering being one of those. Okay, so when you guys, especially if you guys work in EPC company like Rekayasa Industri, for example, you need to know a little bit about other disciplines as well, a little bit from engineering physics or instrumentation engineering, a little bit from mechanical engineering, from electrical engineering, even from civil engineering. You need to know a little bit from those areas as well in order for you to become an effective process engineer. Okay, so there's a strong multidisciplinary approach when you graduate. Okay, that is something that's the way real world works. Okay, we cannot work just by ourselves, but we also need other disciplines as well. And this is a weekly rundown of what we will have this semester. So week 1, we are here, of course, we are in introduction, and then week 2 and 3, we will discuss fuels, okay, types of fuels, their different characteristics, and so on. Afterwards, in week 4 and 5, weeks 3 and 4, we will discuss water processing, okay, and then week 4 to 5 is the cooling water system. So these materials will be given by Pak Wawan. I'm giving this one, fuels, okay, me and Pak Hendra. And then in week 5, we will have module examination number 1, okay, which covers these materials, of course. And then week 6 to 7, we will discuss more about combustion system and also boiler system. Sorry for the typo. Week 8 and 9, we will discuss steam turbines, how to what their design look like, how they operate, and also how to calculate their efficiency and their performance. And in week 9 to 10, we will discuss steam system. So this includes steam generation system, which is the boiler, and also steam distribution system, how to design the basic specifications of steam distribution system. And this actually you will use it next year for your plant design project. Okay, and because next year you will use this, you will design these systems for your plant design project, then we plan to give you a team project sometime here. Okay, so in week 9 or 10, we will give you a team project, which most likely will be about designing the basic design of steam generation and distribution system. Okay. Then in week number 10, we will have the module examination number 2, and then week 11, we discuss about gas turbines. Week 12 is piston combustion engines. So these two, week 11 and 12, actually talks about internal combustion engines, okay, mesin pembakaran dalam. Again, we're not trying to make you into mechanical engineers, but you as process engineer need to know stuff beyond chemical engineering, okay? And these are some of those areas that you need to know. And then in week 13, we will discuss technologies around cogeneration and combined cycle, which the ultimate goal is to save energy, okay? Is to save the environment, to reduce carbon dioxide emissions. And week 14 is we will talk about the introduction to electrical systems, industrial electrical systems, and we close the semester by having module examination 3 in week 15. Okay, so it's easy to memorize. Every multiplication of 5 is exam week. Okay, so week 5, week 10, and week 15 are exam weeks. Now, where does this class sits within our entire curriculum? So here we are, TK3102, Plant Utility Systems, and in order for you guys to successfully complete this class, then of course you will need some knowledge from NMA, mass and energy balances, and also quite a bit knowledge from thermodynamics, because inevitably there will be some thermodynamic cycle and thermodynamic efficiency calculations, which actually the principles of which you have already learned in thermodynamics. Okay, so these should be nothing new for you guys, right? And from here, from utility systems, then I guess the closest course which fits on whatever knowledge that you learn here is process control. Okay, because a lot of controlling action in the chemical process plant is actually made possible by these plant utility systems. So after you guys complete from this course, and next semester you're taking process control, I want you guys to remember what you learned this semester and try to relate, okay? Try to relate one course with another course. Try to reflect back and say, okay, so this is what Pak Walmiki, Pak Wawan, and Pak Hendra taught us, that in order to perform process control action, you need to have these utility systems, okay? So that will give you better motivation as well in learning this class. And then after you guys done with process control, then of course you will enter this capstone design project, okay? Which includes process design and process performance evaluation. No, sorry, this is not capstone yet. But this one is actually part of your capstone design, okay? So TK4101 is actually part of your rancangan pabrik, okay? Process performance evaluation, or FALKIN, that's the popular acronym for it. FLCAN uses a lot of principles that you will learn in this class, utility systems, and also in process control. So in order for you guys to be able to understand how real life industrial equipment behave and how to control them, you need to understand utility and process control. Okay, and this class 4102 will help you understand what's going on when you do your industrial internship. Okay, so again, this all ties together nicely to become your plan design project. Okay, plan design project, and this is chemical engineering economics and project management. Actually, these two classes goes hand in hand because any plan design project is not complete without economic analysis. Okay, and utility actually is one of the major cost component when you design a chemical processing plant. Okay. Okay, well, I think we have already discussed this one. This is just a little bit of a more detailed breakdown of the weekly activity, so we can skip that. M, this stands for module, so this is module number 1, module number 2, and so on. Okay. Oh, wait. Introduction, 2, 3, view, 3, 4. Okay, I think you can pretty much ignore this one. The week numbering is a little bit different. Well, actually not different, but this one is more detailed. Okay, whereas this one is a rougher description of what's going on. Okay, so yeah, we can do this one. Okay, we can let's stick to this one when we plan our detailed week to week activity. Okay, so activities and expectations, right? So the learning will be done online, of course. You guys are not allowed to go to campus yet. The primary platform is ITB EduNext. This replaces the Kuliah ITB ICID from past years. Okay. However, the video conference platforms will be arranged as necessary. So it could be that one day we will decide to use Microsoft Teams. Other days we decide to use Google Meeting, and so on. Okay, that depends on the situation, which one works best, depending on how the network behaves by then. Okay. Now, each class session will typically consist of these activities. So not now, of course, but for this week, for the first week, we will do this the old-fashioned way. But next week's we will try to shift our learning mode, our teaching mode into something that looks like this. Okay, so we will begin by opening remarks from the instructors, which tells you guys what to expect for this week or this course, and then we will give you some time to study, to perform self-study of asynchronous materials, which we will make sure that we will upload those materials before each class, right? And afterwards, we will do synchronous and also asynchronous discussions with you guys. So after we give you some time to review the materials by yourself, then we will reconvene in the class and we will have discussions. Asynchronous discussions meaning discussions through WhatsApp group and communication groups like that. Of our activities will include quizzes, homeworks, team project. There will be one team project. Tutorial and additional discussions will be held as necessary. Okay, and feel free to contact us of ours anytime. So you can drop us email or WhatsApp text anytime, of course. But do allow some time for response. Okay, so do not expect instantaneous response. And please use proper language. Okay? This is part of your engineering skills. Okay, so using the proper language to communicate with your instructors. Okay, and please do keep in mind that different instructors may have different standards about what is proper. Okay, so it's best to be safe. Okay, it's safer to use what is generally accepted as proper knowledge for communication between students and their professors. Okay. Okay. All right, sign in your attendance in CX online system using your own accounts. do not sign in your other people's account. That's a violation of peraturan academic, and actually it's considered to be a serious violation. Okay, so only sign in your names. Do not sign in for you on behalf of your classmates. Okay. Okay, some activities are to be done in group, others are individual. Be professional and participate accordingly. So please do not just log in and then go someplace else. Please stand by your laptop and listen and look at this course. Okay, so just don't sign in and then you leave the laptop. Okay, that's not a professional behavior. Okay. Online learning does not mean compromising on integrity. Okay, on the contrary, we are doing extra effort in ensuring the integrity of your learning process. Okay. Specific instructions will be given for each assignment and test. All students must follow these to the smallest details. So this including rules for file naming. So please please observe those rules down to the smallest details. Okay, this will make our jobs easier. Okay, because now everything has to be done digitally. So your exam papers will be submitted as soft files, of course, and where there's so many students, even a simple task as naming the file has to be done to the smallest details. Okay, because that will facilitate us in managing your files, in managing your works. Okay, and reducing the chance of missing files or misplaced files and things like that. Okay. All module exams must be taken according to set schedule, and there will be no remedials. Okay. Only truly compelling and written reasons will be considered for taking exams off schedule, ujian susulan. Okay, so please act maturely. Jadi mohon bersikap dewasa. Don't use any whimsical reason to for not taking the exams off schedule, because off schedule exam, to be frank, is is extra effort for us. Okay. And you're not the only one that we're teaching this. We also have other responsibilities. So please do as much as possible. Okay, make the maximum effort, your best effort to be able to take the exam on schedule. Yeah. If you're really sick, for example, then okay, of course we will give you ujian susulan. But please use that facility sparingly. Okay, please act maturely. Okay, jadi bersikaplah dewasa. Ya. Ujian susulan bagaimana juga adalah kerja tambah untuk dosen. Ya. Okay, and this is tentative weighting. Okay, of course, tentative meaning this is not final yet, but this is what we do last year, and we will whether we will do it exactly like this this semester, we don't know yet, but this is what we do last year. So module exam accounts for 80% of your final grade. Homeworks, quizzes is 20%. Okay. Okay, any questions here?
Excuse me, sir. Actually, I have questions, sir. I have two questions. First question is, since this is the first time meeting you, sir, can we have your numbers, sir? Your WhatsApp numbers, sir?
Yeah, no problem.
And the second question, in the tentative weighting, sir, for the final grade, since you mentioned something about the group work, where will it be allocated, sir, in the grades?
It will be allocated here. However, the percentage is still not final yet. So if we give you team projects, so chances are homeworks and quizzes will be reduced. Okay, so because teamwork requires more time than homeworks and quizzes. Okay, any other question? Okay, somebody's raising hands. Go ahead, Damalia.
Thank you, sir. I have one question, which is, I noticed there's only module 1, module 2, and module 3 examinations. So there won't be any final exams. And for the module exams, for the weight 80%, how would it be for the breakdowns?
Okay, so your first question is, the answer is no, there will be no final exam. Okay, so module 3 and that's it. Okay, so because this course is modular in nature anyway, okay, so there's between module 1, 2, and 3, the content of the exam will be different, will be separate from one another. Okay, how we are going to to exactly calculate the weights between the model exams. I cannot say for certain now, and the reason is we're not really sure when we give you guys exam, if that exam will be just right for you in terms of difficulty, or will it be too difficult or too easy even for your class. Okay, so what we do typically is, or what I do at least, usually after we're done grading, then we will look at your the class average for each exam. So this is my own policy. Okay, if there's an exam that is particularly difficult for the students, usually I reduce the weight. Okay, so that way it will not drag down your final grade too severely. Yeah, so that's what I do. Okay, but otherwise, if the 3 exams looks about the same, the class average looks about the same, then I will simply divide 80% by 3. That's it. Okay.
Okay, I see, sir. Thank you for the policy, which it would help a lot for us.
Yeah. Okay. Yeah, that's what I've been doing for many years now. So, because and that is especially useful because my own policy, again, I like to include a number of well, not really, but what I do is from year to year, my exam problems tend to be different. Okay, and it's sometimes difficult for me to gauge, okay, to measure whether this particular problem will be very difficult for you guys or not. Okay, so what I do is I will look at exams number 1, 2, and 3 and see, okay, so if the class average is about the same, so it tells me that the level of difficulty of the exam is about right. Okay.
Oh, and I have one more question, if you don't mind, sir.
Mm-hmm.
The class would be recorded, right? And where would it be posted? Is it available for us to download it, or is it would be posted by EduNext and then we cannot download the video?
Okay. I think that Pak Wawan or Pak Hendra can answer that.
Okay.
Yeah, normally the recording is uploaded to the YouTube, and the link of the YouTube will be provided either in EduNext or in MS Teams. I think it's easier for you to watch and download, right?
Yes, sir.
Or from Pak Hendra, any additions?
Yeah, maybe we will try to upload it in YouTube, yeah, and also the link for each meeting or course meeting will be uploaded in the EduNext, yeah. So you can have a check, yeah, in each module, because we will create several modules, yeah, based on the explanations provided by Pak Miki, yeah, and we will give the each link for each course meeting, yeah, in the specific module, so you can have a look through the recording, yeah, later.
Thank you, sirs.
No problems.
Yeah. Yeah, so you will have a variety of materials available for you guys, actually. So you have these pre-uploaded asynchronous materials, and yeah, we will also share with you the the PowerPoints, which is slightly different than the videos, and you will have the recording of each class sessions. Okay, so there are many materials that you can learn. So last chance to fail the class. Okay. Any other questions? If not, we can move forward to introductions.
Miki, maybe I have one additional information, Pak.
Yeah, go ahead.
Okay, maybe regarding the presents, yeah, maybe we will try to use the EduNext, yeah, just for the first meeting. If the EduNext is actually work, so we can use the present from the EduNext. But if it doesn't work, we can use the CX, yeah. So please, for all of the students, have a check in the EduNext, yeah. And the requirements to fill in the attendance list is you must read through the slides that is actually has been uploaded in the EduNext, yeah. So once you read through the slide, you are allowed to fill in the attendance list in the EduNext. So please try it first, yeah. If it works, so then we can use the presents from the EduNext for the next meeting.
Yeah.
Yeah.
Okay. Thank you, Mahendra.
No problem, Pak.
Yeah, so I like that. Students have to read through the materials first before they can sign in for attendance.
Yeah, there is actually a lot of choice, Pak. Whether students read the modules, whether the students need to submit the assignments or quiz that is actually given during the course. So there is Yeah, the good one is from the EduNext is, yeah, there is actually something to do from the students in order to fill in the attendance list.
Okay, good. Okay, Helena, go ahead.
Sir, excuse me, but can I ask for the token for the EduNext thing?
Oh, you are not
Okay.
joined in the EduNext?
Sir, it's weird because like 2 days ago I was enrolled in all 8 classes, but then suddenly like I keep on like losing my courses for some reason, and then they suddenly start reappearing,
Oh,
and then they go again.
Okay. So I'll give you a token later, yeah, through the
Thank you,
chat Zoom.
sir.
Yeah. Okay.
Okay.
okay. Anything else? Yeah, that's that sounds pretty serious if you're losing all of your courses in your EduNext account. Don't worry about it though. That's that's admin problem, so I wouldn't worry too much about it. But I think Pak Hendra, can you help check that out?
Yes, but I will have a check that.
Okay, thank you. Okay, all right. So let's move on to this.
Sorry, I have a question actually.
Yeah,
How
go
do
ahead.
we check? How do we exactly attend in the EduNext?
31.
How do we like check which our attendance in EduNext? How do we exactly do that?
Oh, Pak Hendra.
Yeah, I think once you read through the modules, I think I'm not sure whether the system is automatically fill in your attendance list, yeah. And because there is actually a requirements for this meeting is you need to read through the modules, yeah. So I think once you read through the modules, the attendance will be, I think, filled in automatically, because I tried to use another options, yeah, with this actually submit the assignments, yeah, for another courses. So once the students submit the assignments, it will automatically fill in the attendance list for that students, yeah. So you can try to maybe download and read through the modules. So I think after you read through the modules, it will fill the attendance list automatically, I guess, yeah. So you can try it first, yeah.
Okay. So how do we check if you already attend the class or not?
Yeah, after each meeting, I will import this attendance list into the CX, so you can have a check in the CX.
Okay. Thank you, sir.
Okay.
Okay. All right. Thank you for your questions. And any other questions regarding EduNext? Okay. If not, we can move on. Okay, so just a quick overview of what plant utility systems are. Wait, let me just check my time. So it's 8:33. Okay, so we have about 15 minutes. Okay, so in the chemical processing plants, these utility systems actually play a critical role in supporting the operation of the facility. Now, yes, it is true that utility systems are support systems, but it doesn't mean that they're like second-rate citizens, seperti warga negara kelas 2. In fact, if utility system doesn't exist or doesn't work properly, any plant will not operate properly. Okay, so this is the word supporting system is not to be taken lightly, actually. Okay, so and even though when you maybe you've heard of from alumni or whoever is working in the process industry that junior engineers tend to be placed tend to be assigned in utility departments first. Now, that is not to say that these are trivial work, but actually the purpose of those chemical process companies is actually to make these junior engineers learn quickly, because one of the best way to quickly learn about the inner workings of a chemical processing plant is actually by assigning them to utility departments. Okay, because the wide variety of the utility systems and the way they intertwine intimately with the core process, with the main process. Okay, so these systems include steam systems. Okay, both the generation system and the steam distribution systems, electric power, again, generation and distribution, refrigerants, inlet water sources, compressed air, and so on. Okay, basically anything that is outside of the core process, of the main process. Okay. And the proper design, operation, and maintenance of utility systems are actually quite important. And the reason of that is because utility costs typically contribute to between 5 to 10% of the total cash cost of production. You will learn about this issue again next year in my class, okay, in engineering economics class. In process design, utility systems are almost always considered in developing cost-saving solutions. Actually, when we design a chemical processing plant, or when we re-engineer, when we want to improve an existing chemical processing plant, usually there's not much that can be done to the main process, but there's always things that can be done to the utility systems, which will help to reduce energy consumption, helps to improve the environmental impact, for example. Okay, so again, when we redesign, or when we design, or when we improve the design of an existing plant, the first target is usually not the core process, but the utility systems. Okay, now in some cases, in fact, the availability of an economical utility resource is actually the first question to ask before even attempting to develop a plant. Okay, and I will give you an example here, actually. Okay, this is a good example. Okay, Portland cement plant, which is one of the I think up to now, this is one of the most profitable class of process industry in Indonesia. Okay, because of the extensive construction projects that the government is pushing forward. Okay, and you should know that Portland cement plants are among the most energy intensive process industry in the world. Okay, they consume a huge amount of energy. Okay, for the reasons which is obvious when you look at the process description of Portland cement plant. They involve the calcination, the thermal treatment, high temperature treatment of raw minerals into cement clinkers, and that single processing step actually makes this industry as one of the most energy intensive process industry in the world. Okay, because the reaction mixture has to be heated up to 1,000 to more than 1,400 degrees Celsius. Okay, to effectively change the raw minerals into cement clinkers, and the product is used in very large quantities. So there's cement production plants around the world, not just in Indonesia. They have to work with a slim profit margin. Okay, so because they can only sell their product at a cheap price, then what they do to stay competitive is try to reduce their energy usage as much as they can. Okay, and when it comes to fuel, what is the cheapest and most abundant type of fuel in Indonesia? Can anybody answer? Cheapest, most abundant type of fuel, industrial fuel that we have now.
Coal, sir?
Yes, correct, 100%. Coal is the cheapest fuel these days in Indonesia. So before we even attempt to develop a cement plant, actually there are two questions that needs to be answered. First one is, do we have locally available raw materials? Okay, and this is important because cement is a bulk commodity. You cannot expect a large profit margin for the cement. So that means that your chemical processing plant, your cement plant, has to be very, very closely located to the source of materials. Okay, to the deposits of limestone, clay, and so on. Okay, the second question is, do we have a cheap source of fuel nearby or accessible to the cement plant? In the case of Indonesia, that means can we obtain coal at a cheap price? Okay, if not, then just buy chemical processing plant. Okay, again, and this is really because the price of the product is cheap. Okay, cement, you cannot sell cement expensively. Okay, especially when we're up against these huge Chinese cement plant factories, which I don't know how, but they somehow can produce cement cheaper than Indonesia can. Okay, so this is a cost-saving problem, and in order to save cost, you need to have the cheapest available type of fuel. Okay. All right. So for here, for example, of course, if you construct your cement factory in Kalimantan, for example, there's abundant source of coal. But what if you construct your cement plant in Java? Of course, in Java you have many customers, right? So the market capacity is large in Java, but Java doesn't have any coal, right? So any cement processing plant in Java has to import their coal from here, from Kalimantan. Well, it used to be from Sumatra as well, but coal reserve in Sumatra is nowhere near what we have in Kalimantan. Okay, so when you build any chemical processing plant in Java that runs on coal, chances are your coal will come from Kalimantan. Okay, all right. So energy is actually a major component of production cost. So, and therefore, a chemical engineer must be able to make realistic calculations regarding energy as a component of production cost. So you guys need to be able to calculate, at least in a basic manner, you need to be able to estimate the amount of heat, the amount of steam, the amount of electric power that is required by your process. Okay, and that is something that you guys build as you learn. Okay, as you learn in our Prodi. Okay, you learn about mass and energy balances. You learn about the thermodynamics, heat transfer, momentum transfer, mass transfer. Ultimately, in terms of energy, those knowledge will enable you guys to estimate what is the amount of energy required by my process plant. Okay, what is the electrical energy required by my pumps and compressors? What is the heat, the thermal energy required by my heat exchangers, and so on. Okay, right. Now, forms of energy required per process plants. Heat is especially for chemical reactions, separation of components. Mechanical energy is required for mixing, of course, for separation, and also for transportation of raw materials. Electrical energy is required for certain chemical reactions, electrochemical reactions, especially for heating. Okay, electricity can be converted to heat, of course. Mechanical energy from electric motors, and also do not forget about illumination and also plant instrumentation. Those systems runs on electric power, obviously. Okay. Constraints in energy change and energy exchange, of course, is conservation of mass and energy. Okay, and the last thing should be kept in mind. Okay, so although the amount of energy after and before process, that is non-nuclear process, right, remain the same. This you have learned in NMA and thermodynamica. However, the quality of energy always decreases because of the increase in entropy, right? So, and this is an important part of the entire utility system. Even though energy is conserved, mass is conserved, but quality of energy always decreases from one process to the next one, to the one after, to the one after it. Okay, this is why we need to keep burning the fuel. We need to keep burning, keep the engine running, keep burning the fuel to sustain the operation of the plant, because quality of energy always decreases. Okay, let me give you just one quick example of the last statement. Okay, decrease of energy quality correlates with mechanical work ability. So even though, well, as we all know, yeah, from our thermal class, that mechanical work can be generated from thermal energy, right? We combust the fuel in an engine, and then the engine turns a piston. The conversion of fuel into heat then drives a piston or drives a turbine, a gas turbine, for example, and that gas turbine then results in mechanical work, right? So that's the conversion from chemical energy into thermal energy into mechanical energy. Okay. Now, as that energy conversion process goes, the ability of existing energy to create mechanical work is actually decreasing. Okay. So second law of thermodynamics says that every continuity of process is always followed by entropy increase. Okay. A chemical plant is efficient if it generates entropy increase as little as possible. Okay. Let's take a look at this one here on the left-hand side here. This is called a diesel cogeneration system, right? And I'm sure you guys you guys can imagine that a piston engine, like a diesel engine, okay, big engines like we have in buses and trucks and also industrial diesel engines. Those engines, if you look at the exhaust gas of those engines, the exhaust gas is still hot, right? It's at least it is warm. Okay, so the exhaust gas actually still contains some thermal energy, right? Otherwise it's cold. Okay, gas knalpot, gas buang. Okay, jadi gas buangnya masih mengandung energi termal, makanya gas buangnya terasa panas. Right? So the question is, can we utilize this waste gas that is contained, waste energy that is contained in this exhaust gas? And the answer is yes, to some extent. Okay, the lower the temperature of the exhaust gas, jadi semakin rendah temperatur gas buangnya, semakin susah energinya diambil. Okay, in other words, the energy quality decreases. Yeah. So, for example, in a diesel engine, okay, the exhaust temperature for a diesel engine is too cold to be used as a working fluid to generate mechanical energy. Jadi gas buang dari mesin diesel itu terlalu dingin untuk bisa digunakan sebagai pembangkit daya. Ya. However, it is still useful to be used as a heating media. Ya, jadi gas buang tadi masih cukup hangat untuk dijadikan pemanas, tetapi tidak cukup panas untuk membangkitkan energi seperti halnya turbin gas. Okay, because the quality is not that good. Okay, the energy quality contained by the exhaust gas from the diesel engine is not that high because it's not hot enough. The temperature is not high enough. Okay, so that tells you, this is a real problem for us in chemical engineering, especially with the increasing challenge of conserving energy, of reducing carbon dioxide emission. Okay. All right. Any questions here? I have to leave because I have other appointment. Go ahead if you have any question.
Actually, sir, I'm still kind of confused, sir. Like when you said where like entropy increases, is that like for one batch of like power source? Like for example, I imagined like if you use coal or whatever, as if like it's like in a train, you know, sir, like you put one batch of coal, then like as you produce like as the process run, then the amount of energy the coal can supply decreases. Is that like the logic behind it, sir?
Not really. Actually, any chemical process, okay, any spontaneous chemical process will result in an increase in entropy. Okay, whether it's chemical reaction or the change in physicochemical properties of a fluid in a flow system. Okay, so if that process can happen spontaneously, okay, then the entropy of the system increases. Okay. This goes back to your thermal class actually. So this the interpretation is not only limited to specific type of equipment or specific type of technology, but it applies to everything. Okay. All right.
Sir, I have another question, sir.
Okay.
However, if it's a continuous batch, sir, then like more raw materials will be coming in, right, sir? Wouldn't that increase make the entropy like sustainable? Like, yeah, you get it, right, sir? Like the reaction will keep on happening. It will keep on happening, you know. Is like I still don't get the system where you link it to like the mechanical processes, you know, sir.
Okay. Maybe Pak Hendra or Pak Wawan can help me. I think you guys have taught thermodynamics before, right?
I'm not. Maybe Pak Hendra can explain because the concept of entropy is a bit difficult to explain actually.
Yeah.
But yeah, maybe from Pak Hendra.
Anyway,
Yeah, Pak. Sorry, Pak. My connection is actually. Yes, Pak. What is the question, Pak?
Yeah. What is the argument or maybe example or justification of the statement that any spontaneous process will result in an increase in entropy, in system entropy?
Okay, so yeah, it's actually the entropy is actually based on the, as we know that the entropy can be used, yeah, based on the enthalpy of the reactions and also the temperature, yeah, Pak, yeah? Because as we know that the yeah, it is actually based on the thermodynamics, yeah, we can see that the entropy is based on the enthalpy of reactions and temperature, as far as I know, but based on the thermodynamic system. Pak.
Okay. Yeah. Not trying to avoid your question, but please,
But probably
you can
it is
read your
related to
thermal
the energy.
class notes again.
I think it can be explained, well, it's not properly exact explanation, but I think whenever we have some reaction or some process going on in a chemical plant, there will be some energy exchange, right? The change of form of energy. And based on the law of energy balance, the energy should be in a constant manner, but some energy will be lost, and this loss of energy will be correlated to entropy increase. So when the entropy is increased, you can understand it as that you need more energy to sustain the process. You need to add more energy to sustain the process, because when some process, some reaction is occur, some energy might be lost to the environment. I think my understanding is like that. Hopefully it's not wrong. You can correlate the concept of entropy into the loss of energy. The higher the entropy, I mean, if the entropy is increased, it means loss of energy.
Yeah, especially loss of mechanical energy.
Yeah,
especially energy is conserved, but if entropy increases, then the ability of the system to generate mechanical work decreases. Okay.
And maybe I try to add add some statement, maybe based on the thermodynamics law, it is actually stated that the total entropy of the system either increases or remain constant, as far as I know that it never decreases.
Yeah, it never decreases.
Yeah.
Okay, I think, well, if there's any other questions, maybe Pak Wawan or Pak Hendra can take the questions, because I have to move on to another meeting.
I think we
can close the
already
class now.
passed the time, sir, because I also have class at 9.
Yeah, okay. So I think we can conclude the class now, and of course we can continue the discussion. Is it tomorrow, I think?
Thursday 3 to 5, Pak.
Yeah, okay. So you guys don't have to wait for long if you have a further question. We will meet again tomorrow anyway. Yeah. So thank you very much for your attentions, and hopefully things are going well with your EduNext, with your access to the class management system. We're still looking at other faculty members, how they're managing their class. Some faculty members seem to be enjoying requiring the students to turn on their camera throughout the class. We'll see if that's possible or not, because that will, membebani jaringan. Okay. But anyway, we need to check your attention from time to time as well. Okay. All right. I think that's it from me. Thank you very much, and we'll see you tomorrow.
Thank you so much, Pak Walmiki. And